Thanks. So guys, on the stream, can you please confirm that the sound works?
Okay, that's we switch microphones and we can continue. The pipeline, we start with some unit test. I will have examples in Go that I'm Go developer. I will not switch to another language soon. And we run some in parallel, some fuzzing tests, benchmarks, testing what you need. You make some artifacts. This will be one part that I will demoing about making artifacts and building them, and you put into some registry and your CD pipeline take over, deploy to staging, make some automation for validation and deploy to production. Usually if you continuous deployment, that will be all automatic and or it's nice and happy. I will go about tracing. It's all about tracing. I will not go to metrics and logs. That's not necessary. The traces can wrap it logs and metrics, and you don't need logs and metrics. Traces are the king. And what is trace? Usually you see there will be two main things. I will talk about traces. Trace is set of spans, and one span can be different part of your code. In a pipeline can be the whole parent will be built, and we have the spans for unit tests, integration tests, other parts that I show there. If will be HTTP, that will be different. You need, if you have multiple services, you need context too, and you need context propagation across the services. But that's different story for another type of service than CICD. Span measure unit of work and service, and trace is collection of spans, as I mentioned. The trace looks like this. It's a JSON file usually, and as previous speaker mentioned, their specification is how that this looks is written in that OpenTelemetry. What is important, the specifications are 1.2.0. They are stable. There are no changes there. The protocols are stable, and usually every language support called the stable, that they implement the API and it's stable. It's not that library is stable. Yeah, that's quite misunderstanding that you look on that language is stable, you install the latest version, you update after 2 months and this doesn't work. Yeah, it's exactly what give me this demo that I hit in 0.16 OpenTelemetry 2 months ago, and I make some improvements for this talk. I upgrade to 0.18 and stop working. Yeah. And that's the stable version. Yeah. It's not about libraries. They are waiting for 1.0.0 is stable from code perspective. There will be no breaking changes. And not sure, maybe in Java is already there, but in Go no. But the traces are stable, should be stable. But it's about API and specification that's done, but library is still in progress. You can see some important thing we call events and attributes. Usually you can have name. Quite often you see some not human readable name of trace, but you can use human readable, and it's quite useful. It's you see that this is generated by Honeycomb library that I'm using for instrumenting GitHub actions, and it's very you see that's built, that's name of my pipeline. There is my repository that I'm using for this thing, and number of GitHub actions that you can find easily what GitHub actions correspond to traces. And some details about I just use a few of them. GitHub run ID, repository, CI host. That can be multiple of them. You will see in demo, and you can have custom events that you can add into code, and you can have also links that help you connect between traces. Automatic versus manual instrumentation. That automatic instrumentation is quite good on the start, and special if you don't need to make that changes. Yeah, and I always recommend if you have language that support it, that's not Go, you can use in the beginning, or you always need later some combination. For Go, automatic instrumentation not work as other languages. You can use, if you have Kubernetes, you can use the eBPF version. That's usually make sidecar and all the traces from observation your stack, and not directly from that. It's usable, but I don't have any experience with that. But it's a recommended way how make automatic instrumentation Go. But I have experience with Java, that using some other guys from our company, and they just adding one line to Java config, and that was done, and all works for them. Manual instrumentation is where we go, and I will show in demo. It's usually about you, that you specify which parts you want trace it and what's missing, and give you that flexibility that if you know your code, your pipelines, you exactly know when you see this is important part that I want to have measure, and this small thing I need to measure, that give you all that flexibility, but it's more work. You need to write some code. Open telemetry instrumentation, there is link I will share later. There are usually that approach, and there are links for different languages, how that support works and will be. Was quite interesting that PHP have automatic instrumentation, I think already done. That was interesting for me. Yeah, there are that supported languages now. The .NET, Java, JavaScript, PHP, and Python are supported the classic way. Go is in development, but maybe they will just make that eBPF version. And I think that eBPF version is for Go, but I think that should be for other languages. That's not so language dependent. Tooling for instrumentation CI. I will point a few tools that we go through, and I will make demo 2 of them. There are a few tools that you can use for your CI/CD. If you're using, for example, me, I'm using GitHub Action. You can easily use Trace or Honeycomb build events on OpenTelemetry CLI. Usually anything, Circle CI, Travis, what you want that have some YAML, you can write there. There is very good plugin for Jenkins. If you using still Jenkins, you can use that and give you quite a lot of information. There are other way how you can proceed the CIs, and usually you can get the JUnit XML output from your CI and parse it into Trace. There are a few tools to that approach, and we make it this approach in API many years ago, and using for detection, flaky test, and other things. there is quite good PDF that is here link how create GitHub action workflow to optimize delivery pipeline performance with Honeycomb on GitHub. I will recommend someone who want see a real use case. There is a very good approach how make measurement for flaky test on GitHub. Yeah, and it's quite big that I cannot make it into my talk. And I will show you small tool like as developer called OpenTelemetry Desktop Viewer, and that's help you that you don't need observability backend for development. Yeah? You can run on your machine. It's one small binary, and you can debug your traces without having Elastic or Grafana or on your machine. For CD, it's a different thing. We are in CNCF. There is great CNCF project called Captain that's help you with instrumenting your CD pipeline. If you have, I think, if you have Argo CD, Flux, GitLab, anything, you can easily add the metrics that give you DORA metrics as OpenTelemetry metrics. You can give file deployments as traces. That's very useful, and you can use it for your continuous delivery pipeline. And I will make it for our project that I'm working now, that exactly way how we instrument that. And there is another tool that's called Trace Test. It's from guys who are on behind Cube Test, and there is very good approach for that validation part in your continuous deployment things, that you can make traces, and validation is usually you run the test and you checking the trace outputs, yeah, if it's some error trace or not, and you can easily automate it whole this workflow. For example, for Canary deployments, it's super good way how to do it, and this is open source project that cover that, and it's good to mention that is look good to look into. But we will continue with CI. I don't have enough time to cover everything. The trace is very simple tool. It's by Andy Davis. There is GitHub link. You can look on that. He support grouping, some parallelism. You can also read his blog post that I really like it. It's about that you don't need logging. You don't need metrics, you just need traces, and you can wrap it lock into traces and you get everything. And that's exactly my opinion, and he write nice post exactly about it and how you can use it. It's very simple. You start trace with some on your bash or in your CI, just trace, make some name for your parent, usually that main trace that you need it. You start the group if you need it. Use trace group command. You run the process, trace task, and dash dash and your shell, or execute your go test or go anything, and finish that finishing by trace group finish command, and that's done. You are done. But this approach have some issues. I will mention them later. And how you can point somewhere else, it's very easy. There are these environment variables that usually works for almost every tool that I remember with traces. You give them endpoint that can be localhost or some the observability backend. There is example for Honeycomb, and you get some authorization for them, for example, API key or your dataset, or both for Honeycomb. And that's moving from trace to build events. That's, I think, a great tool with very detailed documentation specified on many CI tools that you can easily find how make that in trace. Travis, Circus CI, GitHub Action. That's some parts are CI tool specific, and that's the main issue with all this YAML programming. The simplest way how you can implement is I will use GitHub Action. There is honeycomb action you can use called GitHub Action Build Events. You provide the API key. That's very easy. You need select the dataset. That's usually some collection in honeycomb that you can go and look into, and you need provide job status. They know if it's failed or success. And there is quite normal action, the checkout, setup Go, and I run Go version, and I need step start that usually just time and date, and some step ID that's name, and build even step will close that specific steps, and you just read that and that's done, and all works, and you get there is link for full example, and you get this from that, and it's nice. You see that I have some init. I have that setup. I built Go. This is my public website that's building in a static generator using Hugo. And I will set up Go. I build Hugo, and I upload my search index to Algolia that I'm using for searching. And it's very easy. You can see on the right side is some things, queries on the right side. You see the metadata, what was that attributes and events. There is no events, just attributes for this use case, and it's easy to do it. But I have one flaw this, and that's what's happened if this failed. If this failed, we don't get any trace. That's the problem. And how you fix it? That's much more complicated. They have another commands that we will go through, and you will see that build even steps is one thing. You need provide the trace ID, as I already mentioned, step ID that identifier for every span. You need make some timestamp for start, and step name that can be similar for or same as step ID, but it depends if you want human readable or not. There is another command that if you need be have more spans and more granularity, they called build events command, and it's similar. You have trace ID and step ID that's the same, but you need make some command name there, and command itself. It's very similar what the trace doing. Usually you provide that command directly, and you will see later how that looks like. There is full example link in presentation. And what is problem with all these systems based on YAML is that if you run some set of that code in the end and failed some step that's ending immediately, and we don't go to the end, and nothing is sent to tracing system. In GitHub Actions, you can make this condition if and command always, and this step will be fired every time. Doesn't matter if some step before failed. It's not perfect too. That we won't run just this for that steps that's corresponding with this end. Yeah, if you have multiple of them, that's getting much more complicated. Yeah, by default the fails doesn't occur in traces. Decoupling have another. First is that default behavior stop remaining workflow on failure. That's this issue. And second is that if you want fix it, you need make this that step always produce some outcome, and you will check that outcome in this always step if contains the failure, and if contains, you fire it. Yeah, that's getting much more complicated. I have much more complex. I will show you later a whole example. You be sure that you follow these steps. Yeah, every step have to have that final step, and ensure with that always that will run it and have that condition that works. And you need append two variables across the code. That's if you want share between two steps, you need share by environment variables in GitHub action. Maybe you use for that you see that you need pass that to GitHub env. That's only way how to do it, and you need source it that and use in that, and you need in this outcome you need to check that previous step is failing or success, and if failed you need fired that, and always, and if it's success that will go through a normal way. And yeah, it's and if you have tens of that steps, yeah, you need to repeat all this, and it's not nice and easy forgot something. I debugged that I'm missing some root spans and something, and that was quite hard to debug, and it's not easy, and yeah, YAML programming is hard. Um, but it's solvable, works, but yeah, it's more about that YAMLs, not about programming, and that's why I don't really like it. And it's dependent on CI. You look on GitHub Actions, that's one way, but if you have Circle CI, that's another way how you make failures. Yeah, and Travis CI have different way. GitLab have different way how work with failures. Their documentation works, and it's quite described if you find the way, but it's not easily changeable, and if you change the CI, it's a problem. You need to rewrite plenty of code. OpenTelemetry CLI is, I think, the oldest tool that I remember for OpenTelemetry for CIs. It's usually very simple. They support 4 vendors or 3 vendors. Lightstep, that was acquired now by Cisco. That's, I don't know if they will work later. Honeycomb, that's usually best observability traces platform in the world now. And Elastic, their APM server works with them too. You run program inside span, you can propagate context via environment variables, you can chain to create child spans. They have advanced cases that you can run the OpenTelemetry in the background, you adding events during that, and you can close in the script. You can make many bash magic there for using OpenTelemetry CLI. Simple example is very simple, as I mentioned. You can use from your command line. You just run it OpenTelemetry desktop viewer, and you can make that export for your local host. You will see, and this command just make my site observable. But we have everything in one trace. Yeah, that doesn't too much. You will see something as this. Yeah. One curl block, and you have some information. And that's why I don't like too much YAML, yeah, that we've moved to better pipelines, and that's in using Dagger.io. I'm not sure if you are aware. Dagger.io is usually a new project for creator of Docker. It's how make pipelines more independent. Usually you run them just using Docker, and you can program them in your own language. Yeah, you can program them in Java, Node.js, TypeScript, Go, QLang, or something else. They are working on GraphQL API behind that, and some modules and other things, and they making a Dagger cloud for running in cloud if you just want to pay for it. And we go how I make that instrumentation in my Go code for Dagger IO pipeline, and you will see you need import a few libraries for OpenTelemetry. It's not just one. It's plenty of them. Usually, the separation of that SDK is as that one mentioned. Exporters are extra. Yeah, you have SDKs. You have resources. You have semconf. That's usually some semantic conversion. How versioning works. There are library for attributes, events, and other things. What is important, you don't need, for example, I am using HTTP, that I don't need gRPC part, now, that separation. I make some instrumentation name, that's just some constant. I make some instrumentation version, that's up to me. You need first define tracer. It's usually the main singleton that you use for instrumentation, and we get some trace provider. We give them instrumentation name, version, and that schema, and some context. And you just create that HTTP client. There is, you see the with insecure that's I'm using on localhost. I don't have TLS enabled, but yeah, skip if you have TLS. And you run that exporter and provider, and that's almost all you need. Don't forget to shut down correctly on the end. That's important things. A few lines you will find in documentation, and just be tricky that as colleague mentioned that its documentation is good. It's not exactly up to date with that versions. That you find something that works in, for example, for Go for that 0 for 16, but if you upgrade to 18, that doesn't work. And they don't mention that documentation is dependent on version. And yeah, it's better go to code and tests how they implement it than read documentation. How that manual instrumentation works? Yeah, the main things is my build function. Yeah, that's what I am running in Dagger.io. You can see there is first thing I need. I'm using that tracer that I initialize on the main function, and I make that root span, and that's called in Dagger. And I add some event and some attributes that I'm using cache, and that's true. And first item that I'm doing is Dagger connect. It's usually connecting to that Docker image that we are using. And what is important here, if I am get error, that's easy here, that I just set status on span to error, and I record that error. And I have all information in that context. I don't need to have some extra if always that's happening. Yeah. It's directly on the side that I have normal errors in Go, and it's very readable and easy to follow, that I get all information. You can add events, attributes, errors, as I show here. Yeah, and we don't have here, but it's important to close the span, and can be quite tricky that sometimes if you make defer on the beginning, that works quite good, but you can manually point somewhere and you find that your trace are completely empty or some different way, and it is good to always check it how you make it, if you instrument manually, how it looks like, and if makes sense for you. And that's why OpenTelemetry Weaver is very useful for your machine. You can easily work with that. Demo. I will show you here, and Deněk. We will have a tutorial. You can find Dagger tutorial in my GitHub repositories. It's usually a simple example. I have here code. You can see there is just one main function. That's all code. We have some dependencies, Dagger, that OpenTelemetry. That's all. Yeah, usually nothing else. It's a small CLI that building some repositories for different version of Go. We support Linux and Darwin, we ARM and AMD, and 2 different versions of Go. And we making matrix that build all these artifacts for us. And as you see in that example, we have that init dagger, that's one span that I make. I get a repository that's main command line parameter that will pass to Bain. We get the source code, and we just make a few for cycles, 3 of them, through the versions, through the operation systems and architecture, and always I make spans about that. That's all. I make some that errors that I point here. I set some environments variable for Dagger and just build it. Nothing else. Very simple. You see 150 lines. And that looks this way. We can go build here. I source the environment variables that give us something, and I run that weaver that you can see that looks like this. It's one binary, very easy to use. You can load some sample data. There is describe how use for gRPC, how use for HTTP, and we just run that, build that application with some repository, and you see that all works. We build it and no errors here. And if we go here, you can see all that pipeline that we done. Yeah, you see the different versions. There is that root span for init dagger, architectures, both, and operation system. And that you see that was built in parallel. I use Go routines. That's usually is, and it's very short that I already have cached all the Docker images. That's quite fast, and it's just small part of CI pipeline. Yeah, that's not everything that we done, but you can see how easy is that. And what is important that you see that that's my local version, but I just need source another part of things that's for honeycomb. I don't show that there is my API key that I don't share with you, and I run the same things for that. And if we go to honeycomb here and we make some query, look what traces are there. We found this trace here, and you see usually the same things. Yeah. And you here you have much more easy to way how you can look on that. If we go somewhere here, you can, there is, for example, that span event that I write there. Yeah, you can see all the informations, and it's very nice. You see the same code, just a few environment variable, and you have in different the backend there, and you can use OpenTelemetry without collector that mentioned guy, or you can have multiple of collectors, depends on your setup in operations. If you have collector in every cluster and one and forwarding to some others, but for developers it's very easy to use, and special with honeycomb that's have 100% of your traces. And it's if you have some special part of your code that you need every trace that works. And what is very good too, that if you have that collector that was mentioned here, you can easily make traces, and they support tail and forward scanning of traces, and you can send, for example, 100% of your errors, but 1% of your good traces, and you don't need spend too much money for Datadog or something. That's quite important feature in collector, and that's make sense. Yeah, the demo is publicly available. You will see there is source code for that, and that. Questions to that?
I have a question. You mentioned that you use GitHub Actions, but do you have any experience with GitLab CI?
Yeah, you can do almost the same with GitLab CI, but that's you just need, for example, build events. They have description, I think, for GitLab CI too. Yeah, but it's that YAML programming. If you use Dagger, you can run in GitLab CI too. Dagger, that's not problem. You can run anywhere, including your computer or any computer others, and it's compatible and works. It's better way. Go that way. We're using Improver, for example, for building our images. More questions? We check Slido if someone online have question. No questions online. Okay. That's thank you everyone that join us today, and back to Zdeněk.
So there will be